Hi people. So today I have created a notebook to estimate the bicycle rentals. This data set was collected by a capital share company, and they have collected it based on different season and weather condition. And the goal of this notebook was to actually see how will the rental demand change after COVID period. And this data was actually from 2019 to 2027. It is has been data has been created as well. So these are some of the features which are present and attributes which are present in the capital bike share dataset. And it was actually a competition which was hosted by the company, and it was a machine learning competition. And I am using a regression models to estimate the rental for the bikes. So when I'm talking about the rentals, uh, why am I using a regression problem instead of a classification problem is because we will be predicting a floating point number from various attributes which are present here. And you can see um, there is date, time, working day, temperature, feels like temperature, like that. They have also calculated the humidity, lowest temperature, highest temperature. So I have created this notebook on Kaggle as well. It is actually a private notebook, but I will be making it public. And you can see I'm loading my data set, and I'm also exploring the different attributes in the data. Some of the attributes are categorical attributes and some are numerical types. And we have a time series attribute as well, a time. So in machine learning, usually when we have time series, then we create lot of features like day, month, and year. So I'll be using pandas and the series method to create different kind of attributes. And I wanted to see the descriptive statistics like the mean, 25th quartile, 50th quartile, 75th quartile, and the minimum and the maximum value for the numerical data types. So here is the different bike data uh, statistical attributes, and here I found that there are numerical features. And also I wanted to see how is the temperature feels like, and humidity, since humidity was also a floating point number here. You can see a floating point number, but there is no statistics for humidity. So I want to see for humidity and wind speed. So this is how you include and see the descriptive statistic for any particular specific features. And but usually one thing is when we see the statistical numbers here, it is not very clear. And we see that there are total more than 380 records. And that's a small data set. So I'll be visualizing this using some histograms and box plots. And I wanted to see the rental distribution, how is it distributed. So it is completely left aligned, and you see the highest point value is 4000 rentals. And the median rental share was um, like 250 times, more than 250 times. Like the rental value was a median value of which is lie between 0 to 1000. And you can see the most frequently occurring values are between 150 to 500, and there are outlier values um, between 1250 to 2000. They do not occur very recently and very frequently, but they are very rarely booked by people. So I also wanted to see how do attributes like different attributes they match together, and the data distribution, since we have a lot of outliers here. And I've created a histogram to see numerical feature data distribution. And I see for the temperature it was usually 15 degrees. And they're very closely related, as you can see. And Though it's not a perfect bell curve for fields like or temperature or humidity, and wind speed is actually different from the above graphs histograms, but their values are somewhat symmetrical, and here it is quite smooth, and the most commonly occurring values are also lying across the mean and the median value, which I have represented using the pink and the teal lines. So I have explored these particular values, and I see that there are lesser outlier values in the numerical features. And now I wanted to explore the categorical values and how do they look like, and what kind of different value counts do they have, what is the granularity. So I saw that when you see object categorical, there is datetime and weather underscore main, but I wanted to, as I told, I segregated the month and the year data, and I also wanted to include another data type called as integer 64, because you see the clouds, weather main, pressure, holiday, working day, these kind of attributes were actually taken by the biking share dataset, and they were encodified, or you can say one hot encoded, where holiday means if there is a holiday or not a holiday, 0 or 1, or working day or not a working day, 0 or 1. So it was actually a categorical data type, but it was represented using integer 64. So it's a boolean value. So that's why I have taken it under the categorical field. The categorical is something which was actually a string, but it was encoded as integers. So that's what is a categorical feature, or you can say a univariate or a bivariate feature variables. And I have actually taken different kind of colors here because I wanted to make my notebook little presentable. So I'm seeing the plot, like I'm trying to use histograms to see how was my data distributed for different categorical features. Here is for day, month, working day or not a working day. Is it a holiday or not a working holiday? So mostly it's not a holiday in this data set. And when the person was booking bike rentals, then mostly the weather was cloudy or it was rainy, and that is what I have understood. And it shows more or less uniform distribution. It is not somewhat asymmetrical. It is not at all like that. So I wanted to see what are the outliers in the data, and that could be done using correlativity of the features, and how close or collinear are the features, and how is the data distributed. So you can see across the x-axis we have the temperature range, and across the y-axis we have the frequency of the bike rental bookings. So from 0 to 2000 we can see mostly the temperature lies between 20 and 30. So whenever it is between 25 to 30 we have highest booking rentals, and in feels like also it is almost similar, but humidity we see that it is actually distributed properly, and we have lesser outliers here. And in wind speed also we see that it is a little bit aligned to the left, similar to the histogram we have plotted previously. Wind speed histogram is over here. It is also kind of aligned to the left. So I have also written some observations for all the graphs, and there was because in the video when I'm uploading, usually YouTube actually takes content to only some amount of time. Like after that amount of time, the video size gets quality gets reduced. So I have to actually edit the complete video. So that's the reason if I'm not able to cover all the descriptive statistical points or the negativity correlation why it was taken, I have tried to write it below the graphs so you can read it. And because I wanted to make the notebook more interactive and user friendly, I've also added some GIFs. Let me know if you like it in the comment section. I'll actually change the settings for my notebook, because this notebook features only explorative data analysis, and I have included a basic linear regression model. I've also tried another regression models. I will make a new video, and so that you can see what kind of regression, different kind of tree based models I have used to estimate the bike rentals. And so this is the box plot, because I wanted to see the outliers in the data, and you can see extreme high data outliers for day, month and year, and also the outliers are present for working and non-working days and holidays, and for weather main. ఇంకేమున్నాయి So here I am training a regression model, because now I was able to understand what were the outliers, and I wanted to show you a basic kind. I wanted to take a basic linear data model and load my data. So I've seen that the day, month and year had a lot of outliers and they needed cleaning. So I've taken some of the numerical features and categorical features as well. The categorical features like fields like humidity, and you can say wind speed. So in the X field the X field is used for training data set, and the Y is for is for the validation or the testing data set. And because it is a linear model, we usually in linear models, when we have actual values and the predicted values, then they try to the linear model tries to map the actual and the predicted values, and the difference like whatever is not actually the difference between both the actual and the predicted values, like this, the difference between these both here, then those kind of errors are called as residuals. And we use that to calculate the mean squared error and the r squared error, and also the r2 error. So the mean residual error is also used to predict like how close is the data, like the prediction, how close is it, and how can we improve our model. So there are statistical metrics which actually tell you if your model is predicting the actual value well. And because when the data keeps improving and it becomes big, then we actually can't keep comparing the actual and the predicted values. So machine learning models like linear model or decision trees or random forest, these kind of trees are used for finding out the prediction value or what would be the bike rental in the future. So you can see my features. It is represented as numpy array as well as the labels. I'm showing you the top 10 features, and I've split it randomly using the train test and split. You can see what are the X train, what is the corresponding Y train, and I've also written what does X test and Y test stand for, so you can read that as well. And I'm training my model using my training data set, that is the feature data set and the corresponding labels, so that the model can actually go through the data and see. And I'll be holding back some of the data which will be in the X test and the Y test. So after training the model, I'll be predicting the model output using the validation holdback data set, that is X test. And we also have the predicted labels here and the actual labels here. So if we calculate the results, then I can actually use a scatter plot. So this is my regression line and this is my scatter plot, where I see the predictions of the actual and the predicted values. I know there is an intersection, but you can also see that the the actual predicted bike rentals had like even 4,000 was the rate value, and it was more values were between 250 to 1,000. So the usually between 250 1,000 we can see a higher scatter plot, and after that there are very less data points over here, but we had to see some data points between 1,250 to 4,000. So those data points in the rentals were missing, so I'm actually calculating the this is a good diagonal trend, but we have some error, and I wanted to know the error value. So we have MSE error, which is the mean squared error, and the RMSE and the R2 squared error. And I have also written what is the difference and what is mean squared error and RMSE and R squared error. And suppose this is how closer to 1 then or 0. 0 means it's a the prediction is actually not closer, and to 1 means it's a very close prediction. So 0.11 is it is an average value, so we can improve these values. And it is a predictive model. It is basic predictive model without any hyperparameter tuning, or I have not used any parameters to fine tune my model and to improve my predictions. So this is the first cycle of the training, and so I'll be improving this model predictions in the next video, and you can check out my new video. And also I'll be plotting the uh, score and the RMSE R square across the scatter plot for different models, and I will try to compare those model performance as well in my next video. So stay tuned and keep checking my new videos, and to get more subscriptions and to get more videos notifications, click the bell icon, and subscribe to my videos to get regular notifications. And if you have any doubts, or um, if you would like to read this notebook, then you can check the Kaggle notebook link below, and if you paste that link, then you can read the complete notebook. And also, if you want to actually check out more Azure cloud data links or GCP links, and any kind of GCP BigQuery and Azure Hive tutorials, then you can check out my other videos about big data code challenge. I have used actual big data over there to visualize sample big data, and also I have utilized Hive and PySpark to um, parallelly distribute my data and partition my data. So they are very interesting tutorials, so you can check them out. Okay, bye bye, see you soon.